Hey guys, we've got some more derivatives today. If you notice, I've already kind of worked out these warm-up problems. These are just extra practice problems that you can try on your own if you like. And we are going to learn something really important and special and exciting today. It's called the chain rule, hence my picture of two chains right here. Anyways, go ahead and work through these warm-up problems. I did not convert those into positive exponents. So just for example, this technically, if it were fully simplified, would be 4 over 7x to the positive 3/7. Remember that those negative exponents drop down into the denominator here. And a good strategy, just something for you to remember, is to rewrite this into fraction exponent form before you try and do the derivative, just because it makes it easier. Then remember, you bring down the 4/7 in front and you decrease the exponent by 1, which means you subtract 7 over 7 from it, which is why you end up with a negative exponent there, okay? So you can try these other two if you like, just for extra practice, but we've done a bunch of them in class, so that's those, and you can pause the video and try those if you like. But I'm going to go right down to the chain rule here. And so what I'm going to do here is we're going to take some derivatives and we're going to use the shortcut. We're not going to use the long way, which is by taking the limit and doing the x plus h and then f of x, all of that stuff. Remember that there are multiple ways to find derivatives. There's the long way that we learned at the very beginning of the chapter, and then there's the shortcut. And so the problem is, what do I do with something that looks like this? Like, I bring the exponent down in front, so I put a 5 there. That's not new. And I decrease the exponent by 1. And what do I keep in the parentheses? Well, you keep the 3x minus 7. So far this is just the regular exponent rule that we've learned. The 5 comes down and multiplies by the coefficient right here, which is just a 1, so 5 times 1 is 5. And this exponent gets decreased, but what are you supposed to do with this inside stuff? So can you take the derivative of the inside stuff? So here, 3x minus 7, isn't the derivative of that just 3? And so what I have to do is I have to multiply by the derivative of the inside. So this is the derivative of the parentheses. And that has to be multiplied if there is a derivative on the inside of the parentheses here. So you do the exponent rule first, and then secondarily, you take the derivative of the inside, which is why I wrote up here, it's like peeling an onion type of thing, outer and inner layers separately. So first of all, do the outer layer first, which means do the exponent rule, and then take the derivative of the inside, which is inside the parentheses, and multiply. So what we can do here is just finally simplify. So my derivative, you can multiply the 5 times the 3, and that gives you 15. And then the 3x minus 7 to the 4th stays. This is the derivative. This is called the chain rule, you guys. The chain is this part, what you have to multiply by at the end. Now let's try a couple more. I'm going to first rewrite this thing. I know that this is 6x minus 3 to the 1/2. Okay, same thing as a radical. A radical is the same thing as a 1/2 exponent. So rewrite it so that we can use our exponent rule. It's just a little bit easier. So that means that my derivative is, I'm going to first bring the exponent down in front. So that means 1/2, 6x minus 3. When I decrease the 1/2 by 1, 1/2 minus 1 is negative 1/2. But then I have to multiply by the derivative of the inside. So what's the derivative of this stuff? It's just 6. And so now to simplify, what I can do is take my 1/2 and multiply by 6 here. So 6x minus 3 to the negative 1/2, which technically should probably be written like this. Or you could write it as 3 square root of 6x minus 3. Same thing. But let's not leave a negative exponent in our answer, okay? So how did I get this 6 again? This is the chain rule, and so if you just look at the derivative of the inside here, the 6x minus 3, remember how this x has an exponent of 1 on it? So I'm going to do the exponent rule with that. 1 times 6 is just 6, and then when you decrease the exponent on this by 1, 1 minus 1 is 0, so the x goes away. Remember that the derivative of just a whole number is 0, so that's why I'm basically ignoring the negative 3. So the derivative of this entire inside here is just 6, and that's what needs to be multiplied for the chain rule. Let's do some more. I'm going to rewrite this one as 3 parentheses 6x minus 8 to the negative 1. It was in the denominator, so I'm going to bring it up by giving it a negative exponent. And now what I can do is take my derivative by using my exponent rule. I'm going to first bring down this -1 exponent and multiply it by the 3 that's already there, which gives me -3. Keep the parentheses the same and decrease the exponent by 1, which makes it a -2. Biggest mistake I see is changing this exponent to a 0. That's actually increasing the exponent. That's not correct. Make sure you're decreasing this by 1, which is how you get -2. Keep the stuff in the parentheses the same. But then I have the chain rule. So what is the derivative of the inside here? The derivative there is just 6. So now to clean it up, I'm going to take my -3 and 6 and multiply them together. So I get -18, the parentheses, to the -2, which technically should be written as this to the +2. There's my derivative. Let's try a couple more. This one already is written as a fraction exponent, so I don't have to rewrite it. I can just start by dropping this exponent down in front. So the derivative, notice I'm always using that f prime of x notation. This is the original function, this is the derivative. Make sure you've got that straight in your notes. So I'm going to bring down the 7/3. I'm going to keep the parentheses the exact same. 7/3 minus 3/3 is 4/3. And now I need to multiply by the derivative of the inside. What's the derivative of this? The derivative of a whole number is just 0. The derivative of this part is just -5. So I'm going to multiply here by -5. Okay, that's the chain rule, and that's because the derivative of the inside of the parentheses here is -5. So that's what goes here. Now to simplify, I can multiply 7/3 times -5, which gives me -35/3 times 3 minus 5t to the 4/3. There we go. Let's do just a couple more here. Okay, this is already as an exponent, so I don't need to rewrite it. I'm just going to start by dropping this 3 right in front and decreasing the exponent by 1. So my derivative is 3, keep the parentheses the same, decrease the exponent. So 4x squared minus 1. And what do I have to multiply by for the chain rule? What's the derivative of this thing? So in this case, I can bring this exponent down in front, which makes it 8. X to the, when I decrease this exponent by 1, I get 1. So I'm not even going to write the 1. And then minus 1, that derivative is just 0. Okay, so again, I can multiply to simplify these things together. Take the 3 and multiply by 8x, which gives you 24x. And then the parentheses, 4x squared minus 1 squared. Boom. Let's try this one. I'm going to rewrite this as 6x squared minus 3 to the 1/5 so that it's a fraction exponent rather than a radical, so that I can use my exponent properties to simplify the derivative. So taking the derivative, first thing I'm going to do is bring this exponent down in front, so that means 1/5. Keep the parentheses the same. 1/5 minus 5/5 is -4/5 when I decrease the exponent by 1. But let's take the derivative of what's inside here. The derivative of 6x squared happens to be, bring the 2 down, multiply by 6, which gives you 12, x to the 1st. So now all I can do is simplify that. I can multiply the 1/5 times the 12x, which gives me 12x over 5, 6x squared minus 3 to the -4/5. And that's a negative exponent, so I'm going to simplify that a little bit more. 12x over 5, parentheses, 6x squared minus 3 to the 4/5. Cool. So a little bit messy, but the chain rule is what is new here. A couple things for you to copy down on the back page. We have another notation for derivative, and all that means is take the derivative of the parentheses with respect to x. With respect to x is what is down here, the dx. That means with respect to x, and you'll learn a lot more about what that means in calculus, but that just means that there are x's in our equation. Sometimes there are t's in our equation, so our derivative has t's in it, and that would mean with respect to t. Or if we were taking the derivative with like a's or b's or different letters or something, that's what this with respect to x means. Most of our derivatives that we're taking here have x's in them, but it could be a different letter, just FYI. So a couple really quick examples here. Take the derivative of this, and so really quickly you can make this 10x, and this becomes plus 3, and that's how you do your derivative for this one. So it's just the exponent rule. Remember, bring the 2 down in front, multiply by 5, that's where I get 10. The exponent on the x decreases, so it becomes x to the first, and I don't even write the 1 here. And then when you take the derivative of 3x, you just get 3. This one, the derivative of 10, well, the derivative of any whole number is 0. Just remember, because what 10 looks like is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a horizontal line. What is the slope at any point on that line? Slope is 0. That's why the derivative of any whole number is 0. Keep in mind why these things happen. And then this last one, the derivative of sine x is cosine x. FYI, just memorize that. You'll learn a lot more about that when you get to calculus, okay? And so now we have a couple things that are like really weird notation, but these are actually very simple. So this notation looks like really crazy. It means basically substitute 6x in right here, and then don't forget to do the chain rule. Okay, so what this means is I'm taking the derivative, so I'm substituting this in here, negative 1 over 1 minus 6x squared. And what is the derivative of this? The derivative here is 6, so that's the chain rule that I need to multiply by. Okay, so the derivative of the 6x goes there, that's the chain rule. Okay, so all I have to do now is simplify that. I can multiply by negative 1 by 6 and get negative 6 on top. And I get square root of 1 minus 6x squared. You could also write that as 1 minus 36x squared. Either way is correct inside the radical. Okay, so there happens to be my derivative. Do a couple more because these are really quick. I'm going to substitute this in right there. So this means my derivative is going to be negative cosecant squared x squared times, what's the chain rule for this? What's the derivative of x squared? Happens to be 2x. So all I have to do is simplify that. So I'm just going to put the negative 2x in front and keep everything else the same. So it's basically more practice with the chain rule. So I'm going to plug this in right here. So I get 1 over 2x minus 1. What is the derivative of this? Just happens to be 2. So I get 2 over 2x minus 1. So it's just practice with the chain rule. Okay, last one, I'm going to plug this in right there. So I get secant squared 4x cubed times, what's the chain rule of this? Bring the 3 down and get 12, decrease the exponent by 1, so you get x squared. So simplifying this whole thing, I'm just going to put the 12x squared in front, secant squared 4x cubed. These are really messy and like ugly kind of and intimidating, but it's just practice, you guys, with the chain rule, okay? That's all. Thank you guys for watching. Have a great night. I'll see you tomorrow.